Good morning, everybody. This is Jeffrey. We're going to give it about a minute here, and then we're going to get started here and just make sure if there's anybody who's late. So hang in there just a minute.
Okay, let's get started, everyone. Welcome again. We're really excited to have you join us for the last installment. Greg Heckler is back, and we'll be completing the clinic on continuous monitors and EPA access control. This is Tom Cerati, president of SMT Supplies, the sponsor for this free online Desco ESD clinic. Before I pass the mic to Greg, just a couple of reminders as per the previous webinars. You will remain muted for the duration of the training, but at any time, please type any question into the Q&A feature. If there are enough questions, we might pause halfway through, but we're going to answer all of them at the end for sure. Each session will last for 30 minutes of training and 15 minutes for Q&A. And then an added one at the end of this session where please stay on. There's going to be important announcements regarding the two promotions that SMT Supplies is going to be providing. Greg, handing the mic to you.
Thanks a lot, Tom, and welcome back, everybody. Again, we thank you for attending all 4 of these sessions now and hope you've been learning something that's valuable for you. This last one, we're really focusing on a single topic, continuous monitoring, or basically personal ground testing, if you will. And then as far as the EPA access goes, I'm sure most of you know, but EPA stands for electrostatic protected area. Now in the standard, an electrostatic protected area is required to be defined. And basically what that means is you should have in writing in your ESD plan where those areas are, or that area, a lab, you know, the entire building, a room, wherever that is. And then typically you would identify those areas with some kind of signage. Maybe aisle marking tape, caution tape, signs on doors, signs on benches, etc., to make sure not only the employees know they're in an EPA, but visitors as well. So that's, I'm not going to spend a lot of time on that, but compliance verification, which we've been talking a lot about these last 4 presentations, has a lot to do with.
Are you moving slides?
No, has a lot to do with EPA access. Okay, so I know Jeffrey can see my slide, but if there's somebody that can't see the next slide, so I'm on the question side, let me know before I get too far. So as far as questions goes, just like we have in the last other 3 presentations, why don't you go ahead and enter your questions if you have any in the questions box or the chat box, and we'll get to those towards the end. I'm not going to break a few times because we don't have a lot of slides in this presentation, so I'm sure you'll be happy with. I know a lot of you like the demos better, so I just have a few demos at the end. So I'm going to go through these relatively quickly. So overview, requirement for testing personal grounding devices. I'll touch on that. The types of testers that we typically use in an EPA. Then I'm going to touch on touch testing, and I'll explain that, what touch testing is versus continuous monitoring. Then we'll get into just a slide of the various types of monitors, and then I'll show you basically how continuous monitoring works. So the requirements for testing. Many of you are familiar with, if not all of you are familiar with the tables in S2020. And we've been talking a lot about also product qualification versus compliance. But as you know, once you've qualified a product for use and once you put that into use in your EPA, now you're following the columns or guidelines for compliance verification. For a wrist strap, groundable static control garment, footwear flooring system, these are all ways that we ground the human body, and you can see the required limits on the right. Now, I may have touched on this before, but personal grounding is the only compliant, or is the only static control requirement that has a defined periodic testing time to it. And that is at least 1 time per day. All other static control items, whether they be floors, ESD matched, chairs, etc., those are all user defined as far as how many times you need to test those. But this is the only one that you're required to test at least one time per day. For foot ground is just a little suggestion. Often what you want to do is test every time that you remove your foot grounders or put them back on. So that's something that's not mandatory, but that's a good suggestion. Okay, so again, compliance verification for this, I'm talking about, after I put the product into use. The other requirement for personal ground testing is that you keep a written test log of that. Now, we've touched on, a lot of you know about, automated or computerized testing nowadays, where you can, download those test results to your computer. That's available now too, but there needs to be some kind of record keeping when it comes to personal ground testing. And in the old days, it was all about, I'm going to talk about touch testing, but it was about keeping a written log in your EPA. And that written log also needs to be easily visible by the employee, and especially for you as ESD coordinators to review that test log from time to time. Okay, I talked about this. Access to EPA, or the electrostatic protected area, should be limited to personnel who have completed appropriate ESD training. And that's not necessarily what we're doing today. That's about the assembler, the people actually working in that area, having some kind of ESD training based on basic ESD training about, knowledge of ESD control. And it may be also some type of training that is limited to what your specific company requires. Maybe that's, like we talked about high voltage one time. You would want to train your employees that you wouldn't wear your wrist strap if you were around that. So you can define your own training plan, but in order to have access, or in order to have a controlled EPA, ESD training is part of that process. Tester types. Okay, this is typical. Testers with a logbook, okay? This is the old standard where we have touch testing, like the person standing on the plate on the right side of the screen there. They plug their wrist strap in, or they're wearing their foot grounders. They press that button and they get a pass or fail, red light, green light. Some testers actually give you whether it's a fail high notice or a fail low notice, for instance, but you need to keep a written test log of that. So, I mean, probably most of you on this presentation are doing this right now. But as I mentioned before, nowadays we have more modern methods, what we call data loggers, or testers that actually maintain this data on your computer network. So touch testing versus continuous monitors. One of the major benefits of a continuous monitor is that you have pretty much instantaneous fault detection. When you're touch testing, or when you're testing your wrist strap, say one time per day, if that breaks 2 minutes after you just tested it, you're not going to know that until 24 hours later. So that's one of the major advantages of continuous monitoring, and why they're so popular. And also, I'm going to get into some intermittent issues, things like that, but that's the main advantage, if you will. The elimination of a written test log. When you're continuously monitoring your wrist strap, the standard says, I don't have to keep that written log anymore. Now, it's still a requirement if you're wearing foot grounders, because you can't continuously monitor foot grounders, but you can eliminate that test log when you're continuously monitoring your products. And then increase reliability. Again, if I have a fault in that wrist strap system, broken cord, anything like that, my cord falls off the band, whatever it is, dry skin, I instantaneously notice that. So if you had to go 24 hours later before you knew there was a problem, there could be some, obviously, damage that you're doing your devices, and you're not even knowing it. Types of continuous monitors. Now, just a little bit of history. The first continuous monitor goes back quite a long time. In fact, here in Los Angeles at Hughes Aircraft, an engineer decided, I'm tired of keeping these written test logs and testing one time per day. And so he invented a little circuit which monitored the capacitance of the human body. Very simple monitoring technology, just has a few components in there. And many of you are familiar with those or may even have them now. They're very inexpensive continuous monitors. The only problem with that is that capacitance changes frequently. It could be you just picking your feet up off your ESD floor. It could be a ballast of a fluorescent light causing problems, laying the cord across your ESD mat. There are ways we can change capacitance, and with that, oftentimes you get a false good. I can't tell you how many times I walk by somebody's wrist strap cord hanging out of a capacitance monitor. They're not even wearing it, and the green light's showing. So over the years, companies, and many of them that we've acquired over the years and invented ourselves, have improved the way that you continuously monitor the human body. So these are various types, but the primary types of continuous monitors that are extremely reliable are the one on the bottom here, the resistive loop, or the dual wire monitor. Again, some of you might have these, there's various brands. And then what we call our wave distortion or impedance monitoring. So the big difference here is with impedance monitoring, I can continue to use my standard single wire wrist strap and cord. And that works pretty much any single wire monitor out there. So what makes impedance technology superior is that it's basically, many of your engineers, a combination of capacitance and resistance. So it's just a much more reliable to monitor the human body with one wire. With resistive loop, basically what you have is you have a wrist strap, a cord that has two wires in it, and it has a special wristband that has two individual plates, and you send a test signal up one wire, the skin bridges the gap on the back of the wrist strap and sends that test signal down the other wire. Basically what that is a fancy continuity tester. So resistive loop monitoring or dual wire monitoring is also extremely reliable. Now there are some monitors out there also that actually monitor voltage on the human body. But for the most part, most of the monitors on the market today monitor either the impedance or the resistance of the human body. Okay, so that was pretty quick. Do we have any questions real quick, Jeffrey, before we get to the demos? And I could go to
Just a quick one here.
Sorry about that. I know we don't have to keep records when we use constant monitors of people testing, but do you have to keep records of calibration?
Well, that's up to your company. Obviously, you have to, if your company or say an auditor, let's say you're an ESD certified company or your program's tied with your ISO program, you obviously have to calibrate things and have records of that to show your auditors. You probably would want to have a calibration sticker on any electronics item, even a torque wrench for that matter, that item was calibrated and when. So yeah, that's a good question, but certainly yes, if you have any kind, if your ESD program is tied back to any quality control process that's being audited, you should have a record of that.
Okay.
And we, by the way, we recommend annual calibration for all of our electronics products. That's up to you whether you want to do that or not, though. Any others, Jeffrey?
No, that's it for now.
Okay, let me see if I can get this camera thing right here. Okay. You see my camera now? Jeffrey, you see me now?
Let's see here. Yes.
Okay. All right, I'm gonna have Jeffrey step over here real quick because I need to see myself too real quick. I don't know why, guys, we can never get this perfect.
I did it earlier. What did I do?
Give me one more second. Okay, now I can see you. I can see me.
Yeah, Greg, you look good. You can
Thank you.
proceed.
Looking pretty tan right now, huh? Okay, so I got two types of testers. The typical touch tester. And obviously the reason why it's called a touch tester is that's what I do, I touch it. Remember everything about controlling ESD on the human body, the standard itself, right, requires that we can't have more than 100 volts on us. When we test things, whether it's a glove or when we talk about human body model damage, it's really all about the fingertip, because that's what we touch the device with. So that's what we touch. That's why we have a touch tester. So this is your basic. This one we call a combo tester X3. This one we can test the wrist strap, and I don't have the plate connected because I'm not talking about foot grounders, but this device actually tests all three devices with a single press of the button. So I'm gonna just oh no, I can put it on my band, I'm sorry. So I put on my wrist strap and I press the button here, and the foot grounders failed, but the wrist strap passed, and on I go. The play would log in their test record, pass, and they move on. Now keep in mind that, remember, for a wrist strap, you need to be at less than 35 megohms to ground. So those test limits are built into these types of testers. This particular one I could change, I could choose different limits if I want, but that's built in. So when I pass, that means I'm less than 35 megohms to ground. Just so you know, if you don't already know, if you get a fail low, that means you're less than the 1 megohm resistance in the 1 megohm for the 1 megohm resistor in the wrist strap. So there's some reason for that failure, and it's typically that resistor is shorted. When it comes to foot grounders, maybe I've got wet feet and I've gone below the resistance. There could be a few things, but it's very rare to get a fail low. But if you do, obviously that could present a safety hazard. You want to have an employee deal with that, and that should be in part of your training process as well. So this is the kind of thing that, yeah, I'm going to test one time per day, and I'm going to log the result, and I'm going to move on. Some companies, you know, might require a couple times, for instance. So when it comes to continuous monitoring, I have a couple of different monitors here. I have a single work surface monitor, and then I have a dual operator monitor, or two people, if you will. But basically, again, the big advantage to these, I'm going to put my, the way these particular monitors work, single wire monitor work, is that, again, the wrist strap cord acts as an antenna, for instance, and then when I'm connected to the monitor, now it's measuring the overall impedance back to ground of my human body. Once again, these testers, like a touch tester, have an upper resistance limit built into them, or an impedance test limit in this case. For the Desco monitor, it's about 10 megohm. So when I'm passing, right now I've got the solid blue light on this. I've also got, this particular monitor has a remote set of LEDs. So I can look up here, for instance, and see green lights. When I'm passing, that means I'm under 10 megohms, which also means I'm well under the 35 megohm upper limit. Now, just so you guys know, is the human body typically has about 500,000 ohms to about 1 meg ohm of resistance built into it. When you add the 1 meg ohm resistor, you're typically about 2 to 5 times 10 to the 6th, or a little over 1 meg ohm to ground. So there's a lot of play in there, that upper limit from 1 meg to, say, 35 meg ohm or 10 meg ohm. And the reason that is you need to take into account all these different parts: the cord, the band material, maybe a little dry skin, maybe somebody's got hairy arms, something like that. You need to have a little bit of play to make sure that you're not right on the edge, which would cause you to fail a lot. So the way these work, I disconnect, I lost my connection, and you can hear that alarm. That's what continuous monitors do. Now there's a big difference between not knowing for 24 hours and knowing instantaneously. In fact, this technology here, it reacts in less than 50 milliseconds. So you know instantaneously whether you have a problem or not. Now, another feature of continuous monitoring is I can also monitor the ground connection points of my mat. Now, I don't have these monitors installed the way you would if you were installing them on your bench and all the wires routed. So it looks like a little messy right here, but this is just for the demo. So this is very important because I get this question all the time. A lot of people think that continuous monitors monitor the surface resistance of the mat, and I can get rid of my resistance to ground testing for my work surface. That's not what they do. What they do is they monitor the resistance between two ground points. So my mat is grounded to my ESD ground back here, and my white monitor wire is back here. If I lose that connection, I get a fault, and it lets me know that my mat is not being monitored anymore. No matter whether I lose that one or whether I lose this one, oh, I have this one screwed on, I'm sorry. Whether I lose that one, your monitor is going to alarm. And so what we've done over the year, that's basically a convenience feature. And it's also a nice feature because I know it's not, the ground connection is not being monitored anymore. But you still have to test your mats regularly. We talked about that, quarterly or however you choose. You still got to check the RTG of your work surface. So in a nutshell, that's how continuous monitors work, and that's the value of them. And again, you don't have to keep the written test log. Now, another tip I want to talk to you about. Another common question I get: people will buy continuous monitors, whether it's dual wire, single wire, capacitance, and the monitor is alarming all the time. So what you want to make sure is it the operator or is it the work surface? And 9 times out of 10, it's the work surface, because you don't have a mat material compatible with that resistance limit built into the monitor. So for instance, on our monitors, it's a 10 big ohm upper limit. So it's important that you have a mat that has a conductive ground plane to it. So when I'm monitoring between points, I'm really monitoring the resistance through this conductive ground plane. So that's just a little tip, that make sure you have a work surface material that's compatible with your monitors if you choose to use that circuit. On our monitors, you could shut the mat off if you want to. That's another feature. So I don't have any questions, Jeffrey?
Greg, yeah, there's a little bit of confusion on how you're leaving the ground cord installed, or the wrist strap cord installed there.
Oh, okay.
Can you explain the parking function and show how that works? I think.
Yeah, I didn't want to turn this into a product show, if you will, but that's a really good question, because it is different than other single wire monitors, other brands, other types. One of the major things that sets, say, our single wire monitor apart is what we have. We have this, what's called a parking snap circuit. And if you have monitors now, you would know that if I pull that cord out of the monitor, I go to break, lunch, wherever, that monitor is going to alarm. Or if I just unsnap my cord, that monitor is going to alarm. So we put a feature on our monitors that allow you to park the cord and keep that from alarming, because that's actually a false alarm. I purposely took my cord out. I purposely unsnapped it. So that's not a real alarm like a broken wire or dry skin. So the way our product works is I can touch this, and what it does is it silences the alarm for about 8 to 10 seconds to allow me to park that cord. Now, in this monitor, the green light goes off, and this LED will start flashing, and it lets you know basically the monitor's on standby. That person's not, in fact, you could walk by the bench, you'd see nobody's working there. So now I eliminate false alarms. The only alarms I want is if I have a broken cord, if I pull my chair away and I yank my cord out of the monitor, whatever, those are the real alarms. So that's another one I'll show you. So after I reinstall my snap, I have about 8 or 10 seconds before that audible signal kicks in again. So now I'm ready to go, and I would have, for instance, a real alarm now. Okay, Or if I take this out, and it's going to be annoying for a few seconds, but if I pull this out, I rip my cord out of the thing. This monitor, or our monitors, will also alarm for a short period to alert the employee that something happened, they're not grounded anymore, and then it will stop. So these are all just really nice convenience features, and features that just also make it easier for your employees to use them. There's nothing more annoying than false alarms. So we've eliminated that problem for you. What you want is a real alarm. I'm using a wristband that the band's real loose and I move and it goes beep. I have a short in my cord, beep. These are all things that you would never know on a touch tester. And speaking to that, I can tell you, I've been doing this a long time. I've never gone into a customer and seen a fail on a written sheet. And what are the odds of that? So if you have them now, or if you ever install continuous monitors, you're probably going to find out that you actually have some broken cords or things that you never know about. Employees just tend to write the date on there and a pass and go to their workstation. Any more questions, Jeffrey?
That's it for now. So, Tom, I think you had a few more things to go over.
Yeah, actually, Greg, I have a question.
Sure.
You talked about either the touch testing or the continuous monitors. Give us a good case study on why a customer should have both.
Would have both? Well,
Should
if
have.
you're wearing foot grounders, you have to have both. You can't
Right.
continuously monitor foot ground. You'd have to have a connection wire wrapped around your ankle the whole day. So you can't monitor foot grounders, so you'd have to have both. Another time when you might want that is the computerized version of this. That would give you an actual timestamp of that wrist strap being tested that day. This one, you're still reliant on the person actually writing their name down. This one, I'm relying on the person to actually plug into it. I mean, that person could work all day long and never even plug their wrist strap in. So that even sometimes you still got to monitor the monitor, for instance. So you may want the computerized version of this, because then I actually have a timestamp. And I have a quick anecdotal story of it. We have a military customer that was having some failures on a very expensive device, and the ESD coordinator was asked by the DoD to go back and show them 3 years of wrist strap test records. That takes hours, days to find all that information. With a computerized system of this, you could do it in a few seconds. So that would be a big advantage also for having both test methods.
Very good. Very good. Next question on, I know you mentioned it briefly, but talk about the calibration again on both units, touch testing and the continuous monitors.
Right. Well, calibration in general, no matter whether it's a tool or a piece of electronics or something like that, is just to confirm that the test limits in the product are being maintained. So we actually don't call it calibration because you typically aren't going to adjust these yourself. We call it limit comparating. So in our products, we have a tester that you can plug in, or a limit comparator, and it just makes sure, for instance, that the 10 meg ohm upper limit on the work surface mat meets, what's in the monitor or what's on the tester. So that's really all you're doing. If you have a monitor or something like that that's out of spec, you may not be sure that you're actually failing low or failing high. And so I'm glad you brought that up too, Tom, because I meant to say on the simple capacitance monitors, some people say you don't have to calibrate our monitors, but that's not true. On a capacitance monitor where it's monitoring capacitance, you not only have to adjust the monitor for the specific person using it, because we all vary in capacitance. I'm a little guy. I'm have a much lower body capacitance than somebody 3 times my size. So you have to dial in that monitor for that person on impedance monitoring, you don't have to do this. I've never seen anybody plug into this that it didn't work with. So you got to be super, super small or really, really heavy, either one. But you still have to verify that the test limits, the impedance limits, the resistance limits are what we say they're supposed to be.
Very good. Yeah, no, that's great, Greg. And speaking of that, is there a tool that customers can buy from Desco to do, I don't want to use the word calibration, but your verification test, right?
That's a common term, calibration, but the difference is that you're typically not, I mean, your Cal Lab, if you had one, could take a touch tester apart, but with this, you need to be able to calibrate impedance. So it just depends on whether you have your own metrology lab or something that you could do that. But yes, all of the test equipment that we make, as far as monitoring or testing of resistance and things, we have a calibration unit or a limit comparator for that you can do it. And for monitors, you'd want to do that. If you only had a couple, you might want to send them back to us. But if you had tens, dozens, hundreds of these, you don't want to uninstall them from your workstation. With our limit comparator, I can walk up and test my monitor in 30 seconds. So you'd want the test equipment or the limit comparator.
Yeah, great stuff, Greg.
We actually have one more question. Sorry to interrupt you guys. Greg, can you have on a SMOC with a hip to cuff grounding system?
Yeah.
Can you show the functionality of that with the tester and with the continuous monitor? Just hopefully people can see that.
So that's a good question. A lot of people, like on this garment that I have on now, we invented a method to improve the grounding mechanism in here that we call hip to cuff grounding. So inside there's this ground snap on the left side of my smock. On the inside of the smock, you can see this black strip here. That's a conductive strip that goes from the snap down to my left cuff here. So the nice thing about that is you're not relying on the fabric of the garment to ground the body. This is like having a built-in wrist strap cord in your smock, and then you're using the cuff of the garment to ground it to your wrist. So depending upon the performance of the smock, I can also ground my body, or I can monitor my smock as well. Okay, and if it should fail, okay, I get an alarm just like I would on a wristband. So this gives you some nice flexibility where I have both of my hands free. So a lot of companies do that now. But all I would say is that it's reliable, but it may not be as durable. Like when you're, oops, let me park this. When you're monitoring, or when you're wearing a wrist strap for personal grounding, not only do our bands, not only are they full of silver, but you have this big solid metal buckle. This is a carbon loaded fabric. So a wrist strap is always going to be longer lasting and more reliable when it comes to grounding the human body. But as long as you pass, that's fine. As far as touch testing, the only problem with this method, you have to remember, I think talked about this before, is that you can't go test your wrist strap here and then walk over to your workstation and snap it to your smock. You need to test it here with your smock if you're going to use that method of grounding the human body. Another thing I want to point out, and I'm doing this right now, see, I have the ground cord just hanging from the tester right now. You'd be surprised how many places I go into, and there's a cord hanging from this tester. And the employee comes up, and they take their wristband, and they snap it on, they test, they unsnap, and they walk away. What do you think the problem with that is? They never test their own cord. They only test this one. So if you're doing that now, your employees aren't testing their own cord. So be sure you need to test your own wrist strap system. Any others?
That's it from the questions box. Tom, you still had some things I think you wanted to go over?
Yeah, very good. Greg, thanks again. Really good stuff. Great session today. Jeffrey, thank you. So
Thank
we
you.
hope you all found today's session to be beneficial, and also we hope you found all 4 episodes. Okay, so let's do a little housekeeping here and tell you what's going on. You're going to receive an email tomorrow from Desco asking to complete a very short survey. We'd appreciate it taking the time, just a couple of minutes to fill that out so we can get feedback and improve these type of things in the future. And then in the next couple of days, we're going to be compiling all the clinic attendance data. For those who attended at least one session, you will be receiving from SMT Supplies a 10% coupon for a single purchase of anything on our website, with a couple of exceptions, like I've mentioned before. And then for those who've attended all 4 sessions, your name will be entered into a drawing to win the new Desco dual operator single wire continuous monitor. And we were talking about monitors today. This is their latest and greatest. It's valued at $235. We plan to announce the winner by Friday. And then just to wrap up, as I've mentioned in the first session, I believe most of you know SMT Supplies, but if not, we're a key Desco distributor. We're located here in South Orange County. We're also a stocking distributor for various production supplies, including solder material, hand soldering and rework equipment, chemicals, cleaners, aerosols, hand tools. I can go on, but once you get to our website, you'll see all our stuff, and we'll give you a link for that. So let's get this wrapped up. Thanks again, everyone, for attending. I looked at the statistics shortly. It looks like all of you have been here for the last 4 weeks. We're really happy about that, and hopefully you got a better understanding of ESD basics. So until next time, Greg, Jeffrey, thank you, and thanks to all the attendees. We'll say goodbye now.
Thank you.
Thanks, Tom. Been a
Thanks,
good 4
guys.
weeks. Appreciate it.
Thank you.